Our next speaker is Isabelle Boutron, who is a professor of epidemiology at the Université Paris-Cité. She's head of the methods research team. She's also director of Cochrane France, a co-convener of the Bias Methods Group of Cochrane, and a member of the Spirit Consort Executive Committee. Thank you, Isabelle.
Thank you very much. Good afternoon, everyone. I'm greatly honored to be here today, and I would like to thank the organizer for inviting me. So my presentation will focus on overcoming challenges to ensure the trustworthiness of primary research. Indeed, evidence synthesis can adequately inform guidelines developer and public health decision only if the results of primary research are trustworthy. However, the current scientific ecosystems mainly relies on the peer review process, where the peer review process will determine which results are trustworthy and could be published. As stated by Richard Smith, who was a former editor of the British Medical Journals, peer review is at the heart of the processes of not just medical journals, but of all science. However, the role of the peer review process is being questioned. First, it is costly and not sustainable. For example, there was an estimation in 2015 that 63.4 million hours of researchers were actually devoted to the peer review process. In 2020, some researchers estimated that the cost of the peer review process was $6 billion. In addition, the peer review process will delay access to the study results, and this was particularly problematic in the context of the pandemic and the COVID-19 pandemic, where a study showed that a 1 month delay in the results of the effect of steroids that was provided by the recovery trials could cost about 200 lives. The peer review process is also subject to bias, and this was very nicely assessed in a randomized controlled trials where the editor wrote 2 fake manuscripts, one identical manuscript, one with statistically significant results, and the other one with non-statistically significant results. Reviewers were randomized to assess one of these manuscripts. And overall, the results show that peer reviewers were more likely to recommend the positive version of the manuscript for publication, 97% compared to 80% for the negative version. In addition, and which was even more interesting, in that they detected more error and provided a lower method score in the negative version of the paper compared to the positive version, while the method section were exactly the same. In addition, peer reviewers don't really improve the content of a manuscript. This was evaluated by comparing the article submitted to the journals to the article published. And it was shown that it had a very low impact on the completeness of reporting and adherence to reporting guidelines such as a consort statement, where there was almost no difference and the reporting remained poor. And they had very low impact also on the what we call spin, which is a distorted reporting and interpretation of the results, where the authors conclude that the treatment, for example, is beneficial, which is not in line with the results. And as you can see on this figure, before the peer review and after the peer review, the percentage of study with high level of spin was quite stable. But the ecosystem is changing, evolving rapidly, and it evolved quite quickly during the COVID-19 pandemic with a torrent of science, as highlighted in a paper in Nature. And what was quite different with this torrent of science was also that a lot of these publications were published through preprint and not initially through peer review journal publications. So the question for people doing systematic review and evidence synthesis was that where can we trust the results of published preprints? Some work has been done evaluating whether the results in the preprint were consistent with the results in the peer review publication, but also some meta-epidemiologic studies evaluating whether treatment effects were overestimated. The results did not go in favor of, were not in favor of bias in preprint, but it was a limited sample, and more research in this field is probably needed when we include preprint in systematic review. Overall, during the COVID-19 pandemic, it was really important to actually include preprint. The other issue with preprint is that it's a living document. So the authors can change the document anytime. And so for systematic reviewer, they will need to keep track on the new results, on the modified results that were reported in preprint. Generative AI is also completely transforming research practice. And some papers fear that generative AI could disrupt scientific publishing or corrupt peer review. An important survey published by Nature, over 1,600 respondents, evaluated what people think about generative AI and how they use large language models. So people using them were using them for very various tasks. It could be to help write code, but also to brainstorm on research idea, to help write research manuscript, to conduct literature review, to help do research, to write presentations, grant applications, peer review report, to draft manuscript, or even prepare a talk. And when we ask researchers how they feel these tools will be in the future, most of them, whether they are currently using AI tool or whether they are not currently AI tool, believe that AI tool will become a very useful, while even essential tool in the future for researchers. Journal editors had to change their practice in front of the situations. And the International Committee of Medical Journal Editors changed its recommendations and wrote that journals should require authors to disclose whether they use artificial intelligence in the production of submitted work. They had to clarify that ChatGPT could not be an author in published article. And they also to clarify that peer reviewers are prohibited to upload the manuscript to a software or an AI technology because of issue of confidentiality. This use of AI for writing a manuscript raised quite a lot of questions, and we see an increasing number in the literature of a fake manuscript, and there was a lot of issue about paper mills that ask for money to produce a fake paper. So some researchers are acting, and this is an example of a tool that has been developed by IT researchers, the problematic paper screening, that was developed by Guillaume Cabanac and Cyril Labbé, a French researcher, which is an automated tool that aims to detect AI-generated articles. And they organize all systems where the tool detects articles using AI, and then they rely on a network of researchers, what we call research integrity truth, that are checking the paper and determining whether there is evidence that this paper is a fake manuscript. And then they're commenting on PubPeer, on social media, eventually contacting the editors. And this work resulted in hundreds of retractions. For example, Springer and Nature retracted more than 300 manuscripts. There is indeed an increase in retractions. In 2023, more than 10,000 research papers were retracted. And the biomed retraction have quadrupled in 20 years. For several reasons, it could be falsification, fabrication, authorship issue, plagiarism, unreliable data, or unreliable results, which are actually increasing. And again, some researchers, IT researchers, try to develop tools and to develop new tools to detect studies that are citing retracted studies. And the idea is that we need to stop bad research propagating through the scientific literature. So you have the feet of clay detectors, where any editors or any authors could come on their tool, enter the journal name, and have a list of all the articles published by the journals that are actually citing a retracted study. You have also the Retract2Bot, which was developed by a team in Oxford that identify articles citing retracted study, but systematically contact the authors of these articles to inform them so that they can act. And more than 100,000 researchers were informed by email that they were citing retracted studies. There is a randomized controlled trials ongoing to see whether it is effective. We used the feet of clay tool because the issue for evidence synthesis, systematic review, and meta-analysis is that we might include a retracted study, which might pervert the results of the systematic review. So we systematically searched for systematic review that had a meta-analysis, including a retracted study. We searched the feet of clay for the 25 highest impact factor journals in the field of general medicine over 10 years. Overall, we identified 52 systematic review reporting 250 meta-analyses, including 67 retracted studies. 73% of the retraction occurred after the publication of the systematic review. But people are still using the result of the systematic review. In 1/3 of the meta-analysis, the retracted study was the only study contributing to the effect estimates. And when we recalculated the meta-analysis, the change in effect on average was not major, but still 12% of meta-analysis changed statistical significance after excluding the retracted study. And 63% of this systematic review reported inaccurate results. Now I would like to highlight the possible role of evidence synthesis methods to improve the overall evidence ecosystem. Indeed, when we are doing a systematic review, a well-done systematic review, there is a strong process which is implemented to detect and account for untrustworthy primary research. Systematic reviewers are going to identify all the information related to a specific study, the registry data, the protocol, statistical analysis plan, the publication, and where appropriate, the clinical study report, and sometimes contact the authors. And then they conduct a standardized and complete, usually by 2 reviewers with consensus, assessment of all this information. All this assessment is completely transparent. And they even have specific tools that have been developed to increase the standardization of the assessment, with a risk of bias tool, TACIT, which is dedicated to conflict of interest, ROBME for addressing reporting bias, and several tools such as Inspect SR for identifying problematic studies. However, this comprehensive and transparent assessment remain within the review report. There is no or very limited feedback provided to the author, to the journal editors, or to the funders of the study. There is no linkage of this assessment to the published report, no posting of this assessment on post-publication peer review platforms such as PubPeer, and no attempt to actually improve the content of the published manuscript or to tag the published manuscript as being problematic. So in a series of 3 articles that were published in the Journal of Clinical Epidemiology under the leadership of Philippe Raveau, we tried to propose to move toward a new research ecosystem, relying on a culture of continuous improvement, where we would bridge the gap between primary researcher, systematic reviewer, and guidelines developer who would work together and take the advantage of all the information that is being developed by a systematic review to actually improve the overall system of the production of evidence and not completely only focusing on the synthesis of the evidence. We should probably also collaborate with IT experts to develop the relevant automated tool that would accelerate this process. So in conclusion, the landscape is changing rapidly with new challenges and also some opportunities that are arriving. We need novel approaches to fulfill stakeholder needs, and we need to move toward a culture of continuous improvement where systematic reviewer would have a key role to play. Thank you very much for your attention.